Okay. In the previous lecture, we've seen that one theorem of second order Euler equation. Okay. What is the theorem? If L of y is equal to x square into y double dash plus a into x into y dash plus b into y is equal to 0, where a and b are the constant. Okay. And the polynomial q of r is given by q of r is equal to r into r minus 1 plus a into r plus b. Okay. So for this second order Euler equation, Euler's equation, okay, the two solutions phi 1 of x and phi 2 of x is given by phi 1 of x is equal to mod x bracket raised to r1 and phi 2 of x is equal to mod x raised to r2. Okay, in the case of r1 and r2 are the distinct roots of q of r is equal to 0. Okay, and if the two roots are repeated, then phi 1 of x is equal to mod x raised to r1 and the phi 2 of x is equal to mod x raised to r1 into log of mod of x. Okay, in case of r1 is repeated with multiplicity 2. Okay, in the previous lecture, we seen that the case number 1, if two roots are distinct. Okay, we proved this theorem. Okay, now in this lecture, we prove the second case if r1 is equal to r2. Okay, okay, case number 2. Case number 2. Okay, if r1 is equal to r2, that is the two roots of the characteristic equation are repeated two times. In case 2, the part 1, a part, for x is greater than 0. Okay, suppose if r is equal to r1 is equal to r2. Okay, then q of r is equal to 0. And also q dash of r is equal to what is the value of q dash of r? आवाज ऐकू येते ना माझा? If r is repeated two times, okay, m times जर repeated असेल तर m minus 1 चा डेरिव्हेटिव्ह काय असतो at point r? ओके, इथे 2 ची मल्टिप्लिसिटी किती आहे? ओके, समजा हा q of x, q of 2 काय आला? 0. What is q dash of 2? 2 into x minus 2 at point 2. Okay, काय येईल? 0 येईल. ओके, q डबल डॅश ऑफ 2 x काय येणार? याचा
0.
डेरिव्हेटिव्ह काय येईल पुन्हा? हा 2x ना, 2 येईल ओनली. ओके, जर एखाद्या पॉलिनॉमियल मध्ये हा जो फॅक्टर असेल तो m टाइम्स रिपीटेड असेल त्याचा रूट्स, रूट्स इज रिपीटेड m टाइम्स, देन m minus 1 डेरिव्हेटिव्ह काय असतो त्याचा? 0 असतो. ओके, सो q dash of r is equal to 0. एनी डाउट अप टू हियर? समजते का मी काय सांगतोय?
Yes, sir.
एखादा समजा f of x is equal to x minus 2 ब्रॅकेट स्क्वेअर. ओके, रूट काय या पॉलिनॉमियलचा? x is equal to
2.
2. किती वेळा आलेलं आहे? रिपीटेड 2 टाइम्स. ओके, f dash of x काय येईल? 2 into x minus 2. ओके, f डबल डॅश ऑफ x काय येईल? ओनली 2. f of 2 काय येईल? 0. f dash of 2 काय येईल? अगेन 0. बट f डबल डॅश ऑफ 2 काय येईल? नॉट इक्वल टू 0. म्हणजेच एखाद्या पॉलिनॉमियलचा जर रूट m टाइम्स रिपीटेड असेल, इथे दोनदा रिपीट आलाय, म्हणजे फर्स्ट डेरिव्हेटिव्ह 2 minus 1 हा कायला 0 आला आणि सेकंड डेरिव्हेटिव्ह काय त्याचा नॉट इक्वल टू 0. Okay, if a is the root, suppose a is the root repeated here, r is the root repeated m times, then m minus 1 derivative at point r is 0. Okay, and m derivative at point r is not equal to 0. Okay, internal ला विचारला होता हा क्वेश्चन. ओके, r is equal to r1 is equal to r2, then q of r is equal to 0, and also q dash of r is also equal to 0. Okay, in case a, in case 1, a part, okay, we proved that if r is a root of q of r, okay, that characteristic polynomial, then the function phi1 of x is equal to mod of x raised to r1 is r1 is the root of q of r, then the function phi1 of x is equal to mod x bracket raised to r1 is a solution of L of y is equal to 0. Okay, in the part 1, in the case 1, part A, we proved the phi1 of x is equal to mod x raised to r1. Okay, now to construct the second solution of L of y. Now to construct the second solution, we have to find the phi2 of x now. Okay, to construct the second solution of L of y. Okay, consider dou by dou r of L of x raised to r. Okay, हे असं काय करतो हे नंतर समजेल. Okay, consider dou by dou r of L of x raised to r is equal to, okay, dou by dou r of what is the L of x raised to r? Q of r into x raised to r. Okay, we proved in the previous part. L of x raised to r is nothing but q of r into x raised to r. Okay, any doubt up here? Reply that idea.
No, sir.
Which is equal to differentiate with respect to r this one using even to will. Okay, derivative of first q dash of r into second as it is x raised to r. Okay, we are going to differentiate with respect to r here, not x. Okay, plus what is derivative of this one? X raised to r. Here x is the constant. Okay, x हा constant आहे तुमचा. आपण differentiate काय कशाने करतोय with respect to r. Okay, so cosine derivative of x raised to r is x raised to r into log x. Is it correct?
Yes, sir.
A raised to x का derivative काय येतोय with respect to x? हा एक constant आहे ना, a raised to x into log x. Okay, हा solution आहे. Okay, derivative of this one and second as it is. Okay, now which is equal to, this is the derivative of dou by dou r of L of x raised to r. If r is equal to r1 is equal to r2, okay, then dou by dou r of L of x raised to r1, okay, which is equal to q dash of r1 into plus log of x into q of r1 to the bracket taking x raised to r1 common. Okay, any doubt up to here?
No, sir.
Which is equal to, what is the q dash of r1? Look at here. Q dash of r1 is the root of q of r, and q of r also is equal to 0, and q dash of r1 is also 0. Now putting the value of this here in this equation, so here we get 0 plus log x into 0 to the bracket x raised to r1. So this is equal to dou by dou r of L of x raised to R1, okay, which is equal to 0 into x raised to R1, which is equal to 0. Okay, hence, but L is what? Differential operator ना, तो हा L differential operator आणि हा differential operator कसा असतो? Linear. Okay, so we can take this outside of dou of dou R. So this is, we can write L of dou by dou R of x raised to R, okay, which is equal to 0. Okay, instead of R1 we can write R only. Why? Because R is equal to R1 is equal to R2. Okay, any doubt? Differential operator हा काय असतो? Linear operator असतो. ओके, हा तुमचा L काय? Linear operator आहे, linear differential operator. लिनियर म्हणल्यानंतर त्याला आपण औषधी घेऊ शकतो. ओके, आता कळालं का आपण असं घेतलंय, का असं कन्सिडर केलंय? बिकॉज this satisfies dou by dou R of x raised to R. It satisfies the L of y is equal to 0. This one, dou by dou R of x raised to R. This satisfies the given differential equation. Okay, hence the second solution of the linear differential equation is also this one, the dou by dou R of x raised to R. Okay, give the reason here. L is linear differential operator. Okay, that implies L of dou by dou R of x raised to R. What is the derivative of this one? X raised to R into log x. Okay, किंवा इथे R1 लिहिलं तरी चालेल, काय अडचण नाही. Okay, which is equal to 0. That implies this function, okay, which one? X raised to R1 into log x. This function satisfies L of y is equal to 0. Hence, the function phi2 of x is equal to x raised to R1 into log x is solution of L of y is equal to 0. Okay, any doubt?
No, sir.
Okay, in the part B part, for x less than 0. Okay, what happens if suppose x is less than 0? Then what we have? Minus x greater than 0. So by a part, the function phi1 of x is equal to minus x raised to R1 and phi2 of x is equal to minus x raised to R1 into log of minus x R, solution of L of y is equal to 0. Okay, आपण x जर पॉझिटिव्ह असताना प्रूव्ह केले तर x जर लेस दॅन 0 असलं काय होईल? मायनस एक्स ग्रेटर दॅन 0 आणि पॉझिटिव्ह साठी ट्रू असल्यामुळे काय होईल? phi1 of x is equal to minus x raised to R1 and phi2 of x is equal to minus x raised to R1 into log of minus x are the two solutions of L of y is equal to 0. Hence, from 1 and 2, combining part A and B part, we have if R1 is the root of Q of R with multiplicity 2, then phi1 of x is equal to mod of x raised to R1 and phi of x is equal to mod of x raised to R1 into log of mod of x are the two solutions of L of y. Okay. Thus, from A and B, we have if R1 is root of Q of R is equal to 0, okay, of multiplicity, two. Then then phi1 of x is equal to mod of x raised to r1 and phi2 of x is equal to mod of x raised to r1 into log of mod of x. Okay, are two solutions of L of y is equal to 0. Okay, any doubt up to here? Okay, हे का consider क्या लगाता है? Consider dou by dou r of L of x raised to r, because dou by dou r of x raised to r, this satisfies the given differential equation. Look at it. याचं satisfy होतं म्हणून तुमचं सेकंड सोल्युशन काय आला? x raised to r1 into log x, height of x. Okay, for x greater than 0 and also less than 0 काय होईल हा? True होईल. Hence combining a and b part, we have mod x raised to r1 into log mod of x is the second solution of L of y. Okay, now we remain to show that the phi1 and phi2 are the linearly independent solutions. Okay, now to prove that, any doubt up to here?
No, sir. No, sir.
Okay, now to prove that phi1 and phi2 are linearly independent solutions, let C1 and C2 be any two constant. Okay, हे काय प्रोसिजर आपल्याला लिनियरली इंडिपेंडेंट दाखवण्याची प्रोसिजर आहे. लेट C1 and C2 be the any two arbitrary constants such that C1 phi1 plus C2 phi2 is equal to 0. जर असं असेल तर C1 is equal to 0 and C2 is equal to 0 आला तर काय होईल तो phi1 and phi2 are the linearly independent solution. Okay, that's why we are considering it. Let C1 and C2 be the any constant. Okay, such that C1 phi1 plus C2 phi2 is equal to 0. Okay, what is phi1? C1 into mod of x raised to r1 plus C2 mod of x raised to r1 into log of mod of x is equal to 0. Now dividing whole equation by mod of x raised to r1. Okay, dividing by mod of x raised to r1. So what we get? C1 plus C2 into log of mod of x is equal to 0. Okay, so this is the equation star now. Now differentiate with respect to x. What we get? C2 is equal to 1 upon mod x into mod x upon x is equal to 0. कशाला समजलं? How it comes? Okay, समजा x माझा greater than 0 असेल तर mod x काय होईल? x होईल. Okay, मग log x चा डेरिव्हेटिव्ह काय येईल? 1 upon x and derivative of x is equal to 1. मग हा कंडिशन सॅटिस्फाय होतो का बघा इथे. तर x हा greater than 0 आला तर इथे काय होईल? 1 upon x. mod x काय होईल तुमचा x होईल upon x. x कॅन्सल 1 upon x. ओके. आणि जर mod x लेस दॅन 0 असेल तर इथे काय होईल मग -x. ओके. मग हा काय येईल तुमचा log mod x 1 upon x into -x upon x. आला का -1 upon x. Log of -x equal to Okay, combining these two equations, we get here C2 into 1 upon mod x into mod x upon x is equal to 0. This term get cancelled, so C2 upon x is equal to 0. Okay, ही कंडिशन कशाला मी सांगेन नंतर. मायनस साठी x लेस दॅन 0 असेल तर काय होईल? mod x is equal to -x. Okay. log of mod x, log of minus x defines नहीं है ना. Let's just mod x. कसा करायला का मला हे 1 upon mod x into mod x upon x. समजते का काही? Hello, am I audible?
Yes, sir.
कसा है 1 upon mod x into mod x upon x. x greater than 0 असताना. मग ऍक्च्युअली त्याला सांगितलं होतं. Wait a minute. Wait a minute, okay? एकच मिनिट. Log of mod x is equal to minus x when x is less than 0. Okay. Mod x, the log of mod x चा डेली काय येईल 1 upon mod x into mod x upon x. Mod x काय तुमचा minus x. Okay. With respect to x. असा येईल ना तो. mod x काय होईल ते minus x equal to 1 upon x. Okay. करते का? So derivative of log of mod of x is equal to 1 upon mod x into mod x upon x. ओके, तसं mod x हा तुमचा डिफरन्शिएबल नाही आहे at x is equal to 0. पण तुमच्या इंटरवल मध्ये not containing 0 आहे. Okay. That's why we are differentiating here. Here we get c2 upon x is equal to 0. Okay. So that implies c2 is equal to 0. Now putting c2 is equal to 0 in equation star. So from equation star, that implies c1 is equal to 0. Okay, hence phi 1 and phi 2 are linearly independent. Thus, if R1 is repeated root of Q of R is equal to 0, okay, then phi 1 of x is equal to mod of x. Phi 1 of x is equal to mod of x raised to R1, and phi 2 of x is equal to mod of x is to R1 into log of mod of x. Okay, phi 1 of x and phi 2 of x. These are the basis for the solution of Euler's equation L of y is equal to 0. Okay, what is L of y? L of y is equal to x square into y double dash plus a into x into y dash plus b into y is equal to 0. Okay, so this is the second part of the proof. Any doubt up to here?
No, sir.
No, sir.
Okay, एकदा पुन्हा एकदा चेक करा व्यवस्थित. ही जरा इथंच कन्फ्युज होण्याचे चान्सेस जास्त आहेत. लॉग ऑफ मॉड ऑफ एक्स ह्याचा डेरिव्हेटिव्ह काय येतोय 1 अपॉन मॉड एक्स इंटू मॉड एक्स अपॉन एक्स. Okay, wait. चेक करूया. समजा x ग्रेटर दॅन 0 असेल तर काय होतो तुमचा mod x इज इक्वल टू x. हा काय होणार तुमचा डेरिव्हेटिव्ह ऑफ mod ऑफ x log ऑफ x काय येईल 1 अपॉन x. सॅटिस्फाय होतो का बघा या कंडिशन मध्ये 1 अपॉन mod x इंटू mod x अपॉन x असं घेतलं होतं ना आपण. ओके सो हा mod कॅन्सल सो दिस इज 1 बाय x. ओके हे पॉझिटिव्हला satisfy the condition. Okay, suppose x is less than 0. So what we get mod x is equal to minus x. Okay, तेव्हा काय derivative 1 upon mod x into mod x upon x. Okay, what is the 1 upon mod x? What is the mod of mod x? Yeah, minus x into minus x upon x. Okay, so this x will cancel minus x and this is also 1 upon x. Okay, any doubt now?
No, sir.
Okay, and we will move towards the example on this. Okay, so this is the theorem. What is the theorem? This one. The basis solution of L of y of Euler's equation is phi 1 of x is equal to mod of x raised to r1 and phi 2 of x is equal to mod of x raised to r2 in case of distinct roots. And in case of the repeated times roots, phi 1 of x is equal to mod x raised to r1 and phi 2 of x is equal to mod of x raised to r1 into log of mod of x. Okay. Now, find next question is find all the solutions of following equation. Find all solutions. Question number 1. Okay. Find all solutions of the following equation. Okay. First one, x square y double dash plus 2xy dash minus 6y is equal to 0. Okay. Answer. Solution. Now, given differential equation is in the form of Euler's equation. Okay. X square into y double dash plus 2 into x into y dash minus 6y is equal to 0. Give it as an equation number 1. Okay, now divide whole equation by x square y double dash plus 2 upon x into y dash minus 6 upon x square into y is equal to 0. Okay, now here what is the value of a and b? Here a is equal to इथे डिवाइड काय केलं हे नंतर काय जेव्हा तिथे नॉन होमोजेनियस इक्वेशन असेल तर 1 वगैरे 1 जर असेल तर इथं काय मग 1 अपॉन x स्क्वेअर वगैरे येईल तेव्हा तुम्हाला पर्टिक्युलर इंटिग्रल घेण्यासाठी तुम्ही 1 घ्यायचा नाही तिकडे b of x 1 अपॉन x स्क्वेअर घ्यावा लागेल म्हणून तुम्हाला काय केलं डिवाइड केलं म्हणून सांगितलं. Okay, now here a is equal to 2 and b is equal to minus 6. Then the characteristic equation of equation 1 is given by then the characteristic equation of 1 is given by q of r is equal to r into r minus 1 plus a into r plus b is equal to 0. So that is equal to, that implies r into r minus 1. What is the value of a is 2. 2r minus 6. Okay, is equal to 0. Now tell me what is the value of r. यही ना है? Is it correct?
Yes, sir.
Required roots are minus 3 and 2. Okay. Hence, then the required solution of equation 1 for, okay, काय म्हटलंय? Find all the solution of the following equation for the पुढे आहे x greater than 0 आहे. Okay. Okay, for x greater than 0, non-negative value, positive values, on positive values except at 0. So then the required solution of equation 1 for x greater than 0 is equal to is phi 1 of x is equal to काय होता तिथे? mod x raised to r1 होता, हो की नाही? आता x पॉझिटिव्ह असल्यामुळे mod x लिहिण्याची गरज नाही तुम्हाला. So hence we can write x raised to minus 3 and phi 2 of x is equal to x raised to 2, that is equal to 1 upon x cube, and phi 2 of x is equal to x square. Okay, any doubt?
No, sir.
जर mod x तुम्हाला ही जर कंडिशन दिलेली नसेल तर काय लिहिलं असतं तुम्ही मग mod x raised to r or mod x raised to r2. Okay, now the next example. One note is there. Okay, note here the given differential equation, ordinary differential equation of second order, है ना? So hence the characteristic polynomial is given by r into r minus 1 plus a into r plus b. Okay, suppose L of y, that is the given differential equation, is of order n. Okay, then what is the characteristic equation? Okay, the name of the characteristic equation also is the identical equation. Okay, identical equation or characteristic equation काही म्हणू शकता. समजा तुम्हाला दिलेला differential equation, if suppose the differential equation is of order n, then what is the characteristic equation? If, look at here, if L of y is equal to x raised to n into y raised to n plus a1 x raised to n minus 1 into y raised to n minus 1 plus a2 x raised to n minus 2 into y raised to n minus 2 up to so on, plus an minus 1 into x raised to n minus 1 to be 1. Okay, so y dash first derivative plus an into y x raised to 0 y raised to 0 म्हणजे y चा 0 derivative म्हणजे y येईल. Okay, is equal to 0. Okay, suppose the given differential equation is of nth order, Euler's equation. Okay, then hence its identical equation or characteristic equation is given by q of r. तिथे सेकंड ऑर्डर असताना काय होतं, क्यू आर इंटू आर मायनस 1. ओके, सेकंड असताना आर मायनस 1 येणार. तर nth ऑर्डर असेल तर आर मायनस n minus 1. Okay, so here r into r minus 1 into r minus 2 up to so on r minus n minus 1. Okay, plus a1 into r minus 1, okay, into r minus 2 up to so on r minus n minus 2. Okay, is it correct? करेक्ट आहे काय प्लस a टू इंटू इथे पहा सेकंड ऑर्डर असताना काय येत होता इथे जेव्हा सेकंड ऑर्डर हे होता डेरिव्हेटिव्ह इथे काय येत होता आर मायनस 1 येत होता ओके जर इथं n असेल तर इथे किती येईल मग n मायनस 1 येईल ना ओके नाही that's why here taken n minus 1 r minus nth minus 1 okay plus a2 into a1 into r minus 1 into r minus 2 up to so on r minus n minus 2 now okay इथे काय सेकंड असताना इथे 1 आहे इथे काय येणार मग या कोएफिशिएंटला r minus 0 ना ओके 2 minus 2 is 0 n minus 2 म्हणजे similarly for nth order okay now a2 into r into r minus 1 into r minus 2 up to so on r minus n minus 3 okay plus up to so on plus an minus 1 into r plus an is equal to 0 okay any doubt so this is the characteristic equation for nth order Euler's equation any doubt up here
No, sir.
खाली लक्ष द्या इथे n मायनस 1 आहे ना ब्रॅकेट काढा आणि इथे काय करा r मायनस n प्लस 1 ओके मायनस मायनस प्लस ओके इथं हा ब्रॅकेट जाईल इथे काय होईल प्लस होईल इथे ब्रॅकेट गेलं तर हा काय होईल प्लस होईल सो हियर r minus n plus 1 r minus n plus 2 r minus n plus 3 ओके इथे शेवटी काय येईल n minus 1 r minus n minus n r minus n plus n cancel only r is present okay plus n is equal to 0 so this is the characteristic equation for the nth order Euler's equation okay now next question find all solutions of following equation for now look at it mod x greater than 0 okay mod x greater than 0 mod x always greater than 0 असेल तुमचा हो की नाही ओके mod x हा काय always greater than 0 असतो फंक्शन याचा अर्थ काय less than mod x okay so first one x square into y double dash plus x into y dash plus 4y is equal to 1 आता पहा तुमच्या हा नॉन होमोजिनियस आहे ओके राइट हैंड साइड नॉट इक्वल टू 0 here so solution x square into y double dash plus x into y dash plus 4y is equal to 1 give it as an equation number 1 now dividing whole equation by x square so what we get that y double dash plus y dash upon x plus 4y upon x square is equal to 1 upon x square so give it as equation number 2 okay now the associated homogeneous equation okay first write down the associated homogeneous equation now the associated homogeneous equation of 1 is of 1 has a homogeneous corresponding homogeneous equation काय येईल right hand side 0 येईल okay so what we have x square into y double dash plus x into y dash plus 4 into y is equal to 0 okay give it as equation number 3rd now what is the characteristic equation of equation 3rd q of r is equal to r into r minus 1 plus a into r plus b what it implies? That implies r into which is equal to 0. Okay, so r into r minus 1. What is the value of a? 1. So we get only r plus b is 4 is equal to 0. So what that implies, r square minus r plus r plus 4 is equal to 0. Okay, so that implies r square is get cancelled, plus 4 is equal to 0. So that implies r is equal to plus minus 2y. ओके, कोणत्याही पॉलिनॉमियलला जेव्हा रूट्स येतात कॉम्प्लेक्स रूट्स ते कॉन्जुगेट पेअर मध्ये येत असतात, एवढं लक्षात ठेवा. ओके, एकच कॉम्प्लेक्स रूट कधीच येणार नाही, ज्या करस्पॉन्डिंग कॉन्जुगेट पेअर ही त्याला येत असतो. Hence the required solution of 3 okay, the required solution of this one complementary function काढायचं आहे. Okay, so that implies I1 of x is equal to mod of x raised to 2y. Okay, this is also true for complex values. हे प्रूव्ह केले पार्ट 1 केस 1 मध्ये आपण. And phi 2 of x is equal to mod x raised to minus 2y. Okay, any doubt up to here? इथपर्यंत काय डाऊट आहे कोणाला?
No, sir.
Okay, now we have to find the value of psi p, particular integral. Okay, what is the b of x here? What is the value of b of x? Not 1, it is 1 upon x square has a b of x is 1. Okay, we know that the solution of equation 2 is given by solution of equation 2. Okay, we know that the solution of equation 2. Okay, who's not equation number 2? Yes, equation 2 is given by psi is equal to psi p plus c1 phi 1 plus c2 phi 2. We know that phi 1 and phi 2. We have to find the value of psi p. Okay, where psi p is particular solution of equation 1 or 2 and is given by the psi p, value of psi p. कसं करतो आपण? In the previous 2 chapters we find the psi p. Okay, psi p is and given by psi p is equal to u1 phi 1 plus u2 phi 2, and we have to find the value of u1 and u2, then we find psi p. Okay, where u1 and u2 हे काढले आपण आधीच्या चॅप्टर मध्ये. Here u1 and u2 are unknown functions to be determined. Unknown functions to be determined. Okay, now case 1. Let's put case 1 for x greater than 0. Okay, if x is greater than 0, that implies mod x is equal to x. Okay, therefore phi 1 of x काय येईल तुमचा? x raised to 2y. mod x हा तुमचा x झाला and phi 2 of x काय होईल? x raised to minus 2. ओके, तो u1 आणि u2 ची व्हॅल्यू काढायची आपल्याला. ओके, तुम्हाला हे झालं का मोठे? पहा असं काहीतरी अजून केलं होतं आपण. u1 phi 1 plus u2 phi 2 is equal to 0. किती होतं?
U1 dash.
u2 dash phi 2 is equal to b of x, है ना?
सर फर्स्ट इक्वेशन मध्ये पण u1 dash phi 1 आहे.
u1 dash phi 1 dash
phi 1
phi 1 dash
plus u नाही सर, फक्त u1 dash phi 1 plus u2 dash phi 2.
आणि इथे काय u1 डॅश phi1 डॅश u2 डॅश phi2 डॅश असं आहे ना,
Yes, sir.
इज इक्वल टू b ऑफ x. ओके, बाय क्रायमस रूल वगैरे सगळं यूज केलंय आपण. इथं phi1 डॅश आणि phi2 डॅश आपल्याला काढावं लागेल, आणि इथं मॉडचं डेरिव्हेटिव्ह तुम्हाला काढता येत नाहीये, म्हणून आपण x greater than 0 आणि x less than 0 असे दोन केसेस घेतोय. ओके, so here if x is greater than 0, what is the phi1? X raised to 2y, and phi2 is x raised to minus 2. Okay, so to find the value of psi p, to find psi p is equal to u1 phi1 plus u2 phi2. Okay, where u1 u1 काय असतो, इंटिग्रेशन ऑफ b of x, विसरला का सगळं, रो स्क्वेअर ऑफ 1, okay, w1 upon रो स्क्वेअर ऑफ phi1 phi2 into dx. This is the u1. Okay, w1 काय तुमचा first column replaced by 0 and b of x. Okay, आणि इथे काय ना u2 is equal to integration of b of x into w2 upon square of phi1 and phi2 into dx. ओके, आहे का लक्षात काही?
Yes, sir.
Yes, sir.
लक्षात ठेवा. Now first find the value of rho square of phi1 and phi2 is equal to phi1 phi2 phi1 dash phi2 dash. Okay, so that is equal to what is the phi1? X raised to 2y, x raised to minus 2, 2y into x raised to 2y minus 2. Okay, minus 2y into x raised to minus 2y minus 1. Okay, after solving this, solve करायला काय येईल, minus 2y into x raised to minus 1. Okay, cross multiplication, minus 2y into हा plus हा minus cancel होईल, x raised to minus 1. Okay, so here you get minus 4i into x raised to minus 1 is nothing but x divided by x. So this is the value of rho square. Okay, now w1 is equal to w1 of x is equal to replacing first column with 0 and 1, and this is as it is phi2 and phi2 dash is equal to 0 and 1, x raised to minus 2y. So phi2 dash is minus 2y into x raised to minus 2y minus 1. Okay, after solving this, value of phi1 is x raised to minus 2y with negative sign. Okay, so this is the w1.
The b of
Okay,
x should be 1 upon x square, na? Why we have taken
b
1?
of x
Yes.
रिप्लेसिंग आपण 0 आणि 1 करतो कॉलम, बघा नाही. ओके, इथं जर b of x नसेल तर मग आपण आता हे करतोय 0 आणि b of x घेतोय. ओके, त्या कॉलम मधून आपण कॉमन काढतोय b of x. ओके, then in w1 we can replace first column with 0 and 1. ओके, हा जर तुमच्या इथे जर नसला असता तर काय आला असता मग तिकडे 0 and b of x, replacing first column in the row scheme with 0 and b of x. ओके, पहा ते थिरम.
Yes, sir.
इथे जर b of x नसेल तर मग इथे येईल 0 आणि b of x येईल. ओके, ते थिरम करताना पहा, प्रूफ करताना आपण असंच घेतलंय. नाव द w2 of x is equal to, now replacing second column, phi1 is phi1 dash here and 0 and 1. Okay, that is equal to x raised to 2y, this is 0, x raised to 2y into x raised to 2y minus 1 into 1 and 1. So that is equal to x raised to 2y. Okay, now what is the b of x? B of x is equal to 1 upon x square. Okay, so hence implies u1 is equal to integration of b of x into w1 divided by root square of phi 1 phi 2, okay, into dx. That implies u1 is equal to integration of 1 upon x square, okay, b of x into root square of w1. What is the value of w1? Minus x raised to 2y divided by root square of phi 1 phi 2 is minus 4i divided by x, okay, into dx. Okay, now cancel this one, this and this, cancel. So this is equal to 1 of x raised to 2y upon x is minus x raised to 2y minus 1 divided by minus 4i. So this minus minus get plus. So into dx is equal to 1 upon 4i integration of x raised to 2y minus 1 into dx. Okay, so that equal to 1 upon 4i. Calculate x raised to 2i minus 1 plus 1 upon 2i minus 1 plus 1, here we get 2i. Okay. Okay.
Yes, sir.
Wait a minute. Minus 12. Minus 12. Wait a minute. Minus minus. W1 minus x. Sorry. Minus x is to minus 12. Okay. W1. Value of W1 is minus x raised to minus 12. So here we get minus 12. It is minus 12. It is minus 12. Okay. So that is equal to minus a. Calculation 8 करा करता ना 1 upon 4 into 2 8 I into I square is minus 1, so this is cancelled. Okay, so this is into x raised to minus 2i, so that is equal to x raised to minus 2i upon 8. So this is the value of u1. Okay, now similarly take the value of u2 now. Calculate the value of u2 now. u2 is equal to integration of b of x into w2 divided by rho square of phi 1 phi 2 of x, that is equal to into dx. Okay, integration of b of x is 1 upon x square, w2 is how about it? X raised to 2y. Okay, so this is x raised to 2y divided by, what is the value of cos t? Minus 4i divided by x. So this x cancel into dx. Okay, integration of x raised to 2y minus 1 upon x is y minus 1 upon minus 4i into dx is equal to minus 1 upon 4i integration of x raised to 2i minus 1 into dx is equal to minus 1 upon 4i x raised to 2i minus 1 plus 1 is x raised to 2i. Here 2i, so that is equal to this I and minus get plus. Okay, so here x raised to 2i upon 8. Okay, so this is the value of u2. What is the psi p then? u1 phi 1 plus u2 phi 2, that is equal to u1 is 1 upon 8 into x raised to minus 2i into phi 1 is x raised to 2i plus u2 1 upon 8 into x raised to 2i. Phi 2 is x raised to minus 2i. ओके, हा तुमचा काय होईल? x to 0 कॅन्सल, इथे किती येईल? 1 येईल. ओके, x to 2i minus x to 2i, it cancel, x to 0 येईल, मग किती येईल? 1. So 1 upon 8 plus 1 upon 8 1 upon 4. So this is the value of psi p. Okay, for x greater than 0. Okay, hence psi is equal to c1 x raised to 2i plus c2 x raised to minus 2i plus 1 upon 4 for x greater than 0. Okay, now case 2. Solve this for homework. Okay, what is the case 2? For x less than 0. Okay, that implies x less than 0 असलं काय होईल, mod x काय होईल तुमचा is equal to minus x. So phi 1 of x is equal to काय येईल, minus x raised to 2y. Phi 2 of x काय येईल, minus x raised to minus 2y. Okay, solve करसाल.
Yes, sir.
Psi p is equal to u1 phi 1 plus u2 phi 2. Okay, now find out the value of u1 and u2. Okay, आता इथं रो स्कीम तुमचा चेंज होईल फक्त. जो इथे डिनॉमिनेटरला आहे काय डिनॉमिनेटरला हा तुमचं काय व्हॅल्यू चेंज होईल, phi 2 आणि हा चेंज होईल. Why? Because phi 1 and phi 2 are with negative sign here. Okay, and find the value of u1, find the value of u2, and using u1 and u2 find psi p and put into the last equation psi is equal to c1 phi 1 plus c2 phi 2 plus psi p. Okay, the answer किती येईल पहा शेवटी. psi p चे answer, wait सांग. 1 upon 4 असेल तिथे. इथे किती येईल psi p तुमचा 1 upon 4 असेल. Okay, then using combined case 1 and case 2, at last we get psi is equal to c1 mod x raised to 2y plus c2 mod x raised to minus 2y plus 1 by 4. Okay, हे सॉल्व करा. तिथे ही psi p किती येईल शेवटी 1 upon 4 असेल. Okay, any doubt up to here?
No, sir.
Solve this for the homework. X squared into y double dash minus 3x y dash plus 5y is equal to 0. Okay, the homogeneous आहे त्यामुळे psi p काढायची गरज नाही तुम्हाला. Third one, x squared y double dash plus xy dash minus 4 pi y is equal to x. Okay, fourth one, x squared y double dash minus 2 plus I into x into y dash plus 3 into I into y is equal to 0. ओके, तुमचे इथे a आणि b काय तिथे इरॅशनल नंबर आहे. ओके, इथे तुमचा 1 आहे. इथे a काय तुमचा कॉम्प्लेक्स नंबर आहे, a आणि b कॉम्प्लेक्स नंबर. नीट रूट्स फाइंड करा त्याचे. ओके, एनी डाउट अप टू हियर? Wait a minute, I will take that in this. Okay, any doubt up to here? काय डाउट असले विचारू शकता.